Hello everyone. In this chapter, I'm going to lecture about inactivation and activation of biologically active molecules. And there are different mechanisms of this activation and inactivation, such as for inactivation, direct inactivation, indirect inactivation, receptor modulation, ADCC, that is antibody dependent cell mediated cytotoxicity. In case of activation, there are also several mechanisms like conformational stabilization, increased binding affinity, receptor selection, buffering, receptor activation, etc. So, in this chapter, we learn about this mechanism. Okay, so first, let's try to get the idea what do we mean by activation and inactivation of biologically active molecules. There are several biologically active molecules in our body, okay, which perform particular or specific works, such as, for example, hormone receptor, blood clotting factor, growth factor, or enzyme, drug. Okay, these are some example of biological active molecules, and antibody can be produced against this biologically active molecule, which can inactivate them or activate them or protect them or may have no effect on them. Okay, so because of this, the activation or inactivation, disease can occur. Okay, but what will be the type of disease will depend on the type of those biologically active molecules. For example, insulin is a hormone, right? So antibody can be induced against the insulin and they can inactivate the insulin. So you know what will happen if insulin get inactivated, diabetic condition will occur, right? Okay. uh, Anyway, so the antibodies which can active or inactivate the biologically active molecules can be produced under different circumstances. Okay, these are some circumstances of those circumstances where the antibodies can be produced against the biologically active molecule. So, such as breaking of tolerance with autoantibody productions. So we know autoantibody, right? So the body will may produce antibody against its own biological active molecule. Okay, so another circumstance, immune response to therapeutically administered hormone, for example, insulin. Okay, or enzyme, blood clotting factor, or drug that is recognized as a foreign antigen. Okay, then uh, biologically active molecule, okay, that is released into the body produced by an infectious agent. Okay, so due to infection, okay, such as, for example, because of some infection, toxin can be produced. Okay, toxic biological molecules can be produced and released by the cell. Okay, so whenever this kind of biologically active molecules are produced by the infectious agent, our body can produce antibody against them and cause the activation or inactivation. Okay, then another circumstances is a specific immunization with a modified toxin of an infectious agent. Antibody can be induced against the toxoid. Okay, we know what toxoid is, right? Toxoid as the kind of, that version of the toxin which don't have the, which cannot cause the toxicity, but can cause, but retain the immunogenicity, right? They cannot cause the disease, but yet induce the immune system. Okay. Okay. Anyway, so first we'll, I will talk about the inactivation. Okay, inactivation of biologically active molecule. Okay, and there are several mechanisms. However, among those mechanisms, four are major mechanisms by which inactivation of biologically active molecules can happen. Number one, direct inactivation. So what happens here? By direct reaction with the biological active molecule, resulting in a structural alteration of the molecule so that it is no longer active. Such as in this figure, say this enzyme, it's a enzyme, it's a biological active molecule. Antibody binds with the enzyme and altered its structure. Okay, thus making it non-functional. So thus inactivating it. Okay, so indirect inactivation is structural alteration of the biological active molecule make it inactive. Okay. Second mechanism, by causing increased catabolism of the antibody antigen complex, which effectively lowering the concentration of the biological active molecules. I mean, in this case, the antibody don't alter the structure of the active molecules. Rather, I mean, the antibody antigen complex, their their catabolism increased. Okay, that means they get like phagocytes, they get phagocytes cytized or lysed quickly. Okay, and because and due to that, the concentration, the amount of antibody and antigen will decrease. Okay, okay, and thus causing the inactivation. Okay, that's why it's called indirect inactivation. The antibody is not altering the structure in the biological active molecule. Rather, they are influencing the influencing to increase the catabolism rate of antibody antigen complex. Okay, so that's why it is called indirect inactivation. Such as in this figure, antibody bind with the active molecule, and then they I mean then they influence the complement fixation, right? So if the complement fixation occurs, then they can get then phagocytosis of this complex can occur, right? And if phagocytosis occur, it means they will get lysed. Okay, they will be get cleared from the body. Okay, okay, and third mechanism, by reaction of antibody to cell surface receptors. Okay, and this reaction can cause blocking. Okay, that means steric hindrance. Okay, or modulation, that means endocytosis or destruction of the receptor, so that the cell is no longer able to respond to activating stimuli. That means in this case, the antibody, they inactivate the inactivate the biological active molecule. Okay, in this case, that is the biological active molecule is receptors. Okay, and when the antibody binds with the receptors, they can inactivate in different way. So, for example, if you see this figure 1, antibody, okay, it binds with the receptor of the cell and block them. So, if the antibody block that receptor will not be able to bind with its target, right? Okay. Thus, this will make the receptor inactivated. Okay, so this can happen, or after the antibody bind with the receptor, this kind of endocytosis can occur. This is called receptor modulation. Okay, if endocytosis occur, this receptor will be no more functional. Okay. Okay, or they can just or the antibody after binding with the antigen just can destroy the receptor. Okay. Okay, another mechanism, number 4, the attracting inflammatory cells that destroy the surface receptors, okay, which is called ADCC, okay, and the loss of receptor function and destruction of certain target cells in some tissues such as insulitis, thyroiditis, atrophic gastritis, and myasthenia gravis are often associated with the lymphocytic infiltrate. Okay, and this reaction, these things can occur maybe due to T cell mediated immunity or auto anti receptors. Okay, auto anti receptors means antibody which has been produced against the receptors. Okay, auto receptors may direct ADCC. Okay, so which means actually what happens in this number 4 mechanism, the antibody bind with the antigen. So like if you see this figure, the antibody bind with the receptor, and then they can activate the ADCC pathway. Okay, so that means after binding with the receptor, they may attract the natural killer cell. Okay, or they may activate the complementary systems. Okay, so eventually, they will be get lysed or destruct, or they will be destroyed by the ADCC. Okay. Okay, so these were, these are the four mechanism, okay, which I just I talked briefly about those things. Okay, so now I mean in the next video lecture I will talk in more details about this mechanism. Okay, till then be safe. Thank you.